in the execution forum and how these processes are able now to work with those platforms that we have. So that's why we have to look at different levels of execution. And these levels of execution that we have is where we can now understand we cannot execute first job if you have not executed the previous job. So for you to execute file management, maybe you have executed memory, because we move from down upwards. We move from down upwards, making sure that now we are starting from this point. User has already distributed. The user is able now to work with application because now they have been communicated through this, what we call the service system services. So we move from down, go to process scheduling. The processor is able to request some services where we say we cannot do memory management if the processor scheduling is not working. So we must look at those platforms that are created within here and be able to look at why we need to have the right communication in them. So in this case, maybe we understand the platform that this is where we are creating different sections of communication, but irrespective of that, we have some disadvantage in this. And one disadvantage is that this module here has to wait for this module to complete. So why can't we execute jobs wherever we want at any time that we want without failure? So that we can maybe rectify the issues that we have in communication. But that's why they went to what we call the microkernel operating system. So in this microkernel operating system, we are providing small executions. These small executions that we have are the ones that are now resulting to what you call characteristics of a modern operating system. One, it does what you call pipeline. Pipelining means the next provide is what you call multi-threading. Multi-threading comes from the one threads. And in this case, we are talking about a dispatchable unit. Dispatchable units in operating system. And these dispatchable units in operating system, they are now allowing many processes to execute it. Like now we are providing a certain platform here, but there are many objects that are executing it. So if we require read, write operation, any other operation, it is now catered by these threads that we are having here. So these threads can be able to execute what you call multi-threading. It is able still to allow what you call object-oriented design. So we are having different objects in communication that are able to communicate with one object to another in that execution. So that's why we are saying microkernel is the center, and we have various servers. These are servers that are able to do multiple jobs. We say jobs, multitasking, and they are able now to send to the microkernel. So here we have send. This arrow that is continuous is said. This one is receive. The request. Then after that, application. In this class, we can have millions of jobs at a given time without failure. And that is what we are supposed to embrace in that communication the moment we are using what you call the three main structures of an operator. So that was an introduction that maybe we did last week, of which you'll be able to see the video. I have still recorded another video here, but we had an issue. I was not recording fast, but I have recorded now. But we have all the notes on your portal and the videos. So is there any question up to that point?
No. You are now unmuted.
Is there a question?
No.
Is there a question?
No.
So we can continue.
Yes.
Okay, so the next question, the next thing that you are supposed to continue with them is what we call process management. That is now the next topic that we were supposed to start with. And when you look at process management, there are things that we need to look at here before I display. In this process management, we need to understand that definition of a process. And I think we have talked about definition. A process is a step-by-step approach of executing a certain job. Or we can say a process is a unit of execution. A process is a unit of execution. And being a unit of execution, we can say a process is a thread. A process is a thread because we have said a thread is a dispatchable unit of a process. So we need to look at definition. Then at this time, we still need to look at now, why do we need a process management? So the purpose of process management. The purpose of process management is always to make sure that now there is management of resources within a process. If you look at an operating system, it has to do these activities. One, it has to delete. Maybe if you are deleting a file, it has to add a file. Maybe it can create a file. You know, there is a difference between create and adding, and many others that we have, etc. Because we have many operations or many activities that we have that an operating system can do within a given time. So in this case, if an operating system can do all these, when is it doing it? So that's why we always look at now what you call when is it doing it? So we need to do what you call process manage. And when you process manage, which you call process management, is when we are looking at, we keep track of all processes that are executing and when are they supposed to end and when they are supposed to continue in the execution. So in this case, if you look at the process management in the execution portfolio, we are looking at a point where now it is very hard for this operating system to determine when it is supposed to execute. So it is now resorting to two-state model. There is two-state model, and one state model that is providing within here is what you call the running state and what you call not running state. So if a process is not executing, you must keep track of that process that is executing. So it has to keep track of the process executing and the process that is not executing at a given point within the execution to avoid process loss within the execution. So all these now resort to understanding now a very clear way how the process moves from one point to another. So when a process is executing is when the process is in the CPU. When it's not executing, has been suspended, terminated, or aborted, because we can abort a process. And when you abort a process, it means that process will never execute because it is premature, or we have done away with it completely. So in this case, we can have now the five-state process. The five-state process, and I think I can use a diagram because of the structure that are provided within that. And before that, maybe, okay, this is what we need to have. Remember we said process a program in execution or unit of execution. But this process should always have this component, object, program, data, resources, etc. status. And when you look at this, this is not new to you because when you're executing a job, you are sending an SMS. What do you require? You require the title, or maybe you require the message in title. Then the message title, you need to look at now who is supposed to receive the message. You need to know the resources that you are supposed to use. Maybe you need to know when is it supposed to execute on that. And that's why we are saying all these process states, because now these are the process states, we must go through them. And when you go through them, one of them, we are moving from this point. We have new, we are the meter process. When you are the meter process, now we take it to the ready queue, meaning this process is in the user's view. This process has been taken to the queue. It's like when you go to a bank, you move from home to the bank. You be the first one or the second one. Then from there, now you can be directed on when you are supposed to execute and how you are supposed to execute in the execution. So in this case, we can look at now, we move from ready to running. So when you move to running, now automatically this is where the process is in the CPU executing. So that's why we are calling it dispatcher. So this dispatcher, another name for that you can call a dispatcher is what you call the short term, because we require very little time in the execution. And there's very little time in execution. We assist in executing millions of jobs that we have pending or on a queue. But it is not a mass this job can complete, we have timeout. So we can time it out. We take it to the ready queue. So what we can have here, so maybe we can draw a text here. What we can have here is what you call input stroke output wait signal. Here we need to have input stroke output said. Maybe here we can have input stroke output said signal. That is what you are supposed to have. This is not new, sorry, I'm sorry for that. This is what you call blocking. This is what you call blocking. So a process can wait because one, there are less resources to be used. It's like now when you are going to school, maybe there is we don't have enough money to take you to school, and we have about 2 or 3 kids that you're supposed to take to school. Now, first of all, you can block some kids. Maybe you block those are not superior in the provision of those resources first. So in this case, one, it is because resources has been aborted. It is because there is hardware failure, or maybe the memory is not enough to be used for the execution. We can block. But when you block, the moment you find that the resources are there now, they can be used, we unblock. So there is blocking and blocking of processes. And you take it to the ready queue. And when you take it to the ready queue, now it can be used for the execution. But now we have what we call the termination, when the process is now ending the executions that we have. So in this case, a process moves from here up to here or up to here. So this is successful completion of the program or execution of that program that we're executing. And now we cannot allow maybe other jobs to execute at a given point. So in that, we find that now maybe these processes are able now to execute, but through provision. I think you can remember we talked about the process control block, which is now moving from new to that, because when you're identifying a process to execute, we move it from the new. So in this area of execution, I think I will send this note so that you can see the structure of the PCB. You require a pointer, the process state, which is currently executing at that time. And that is what we need to understand with the process execution. So something to note here, when you are executing, there are some criteria. There are some criteria to observe. I think we can use a new slide here. Maybe we can say criteria used in process management. One criteria that you need to observe is what you call the waiting time. One is waiting time. The next one is what you call the throughput. Then we need to use what you call the response time. Then from the response time, maybe you can look at what you call the turn time. Do you have any issue? So Esther, I think you can switch over. Mr. K, I think. So Esther, I think you can switch over. Mr. K, I think can. Okay. Okay.
Yes. Yes, sir.
So welcome. So welcome. Esther Akini, please can you? Esther Akini, please can you? Okay. You are ready now. Okay, I think you can switch off your mic if you are not maybe communicating. Maybe you can switch off your mic.
Okay.
I think, okay, I will not repeat introduction again. There is a video that has been sent, or I sent. Please read. If you have a question, you can ask. I will repeat next time if you have a question. I have repeated again with Akinyi. Please, if you have a question, you are free to ask a question at any time.
Okay, sir.
Okay, so I want maybe to try to understand the pros management, because that is now where we need to look at. Because when you look at the operating system, most of the things that you are doing with the operating system is processing jobs. But when you are processing jobs, you cannot wake up today and we say we are processing jobs. So you have to look at now, when are we supposed to process it? Why are we processing it? And how will you do so that now we will not restrict the access of others? It's like now you have a family of 10 children, and all these are all kins, between 1 and 10. Maybe the difference was 1 year. Or maybe we have up to 1 to 8. So all those are kins. So how will you treat them? So we must look at now the criteria used in PROS management. So managing that now, we can process them without failure. And one of them that we have talked about is the waiting time. And I think this one is not new, because it is the time you wait to execute. Like now, if you have process 1, and then we have process 2, how many minutes will I wait for process 1 to complete? That is the waiting time. When you talk about throughput, this is where now we need to understand more. It is the amount of job or average number of jobs, amount of job that can be executed in a given time. So how many jobs will you execute in a given time? I have given you a job, e.g., maybe we can say I have given you a job from 9, then up to 10. So how many jobs have you completed from 9 to 10? Maybe 10 jobs or 1 job. Within 1 minute, how many jobs have you completed? So we are looking at the average number of jobs that you have executed. And that's why we understand that when you come to operating system, we always understand that we need to execute many jobs. That's why we always say that the CPU should not be idle. They should not be idle, because we need to execute many jobs. Should not be idle. Should not be idle, because we are executing many jobs, and the jobs that we are executing, we must keep on piling them, because when the CPU is idle, we are now reducing what you call the system clocking of the system, or program counter. Then the next one is the response time. Now, I think this one you can explain the time that you take to respond to a certain event. When I call you, how many minutes have you delayed so that you can access or maybe respond to a certain event? Turnaround time is the actual time, or the time taken from first, let me use that, from first job to the last job. If I was executing the word ZTech, how many minutes have I taken to execute Z up to C? So if I have given you 20 jobs, now you have executed 20 jobs from 9 to 10. So how many minutes have you taken? You have taken 1 hour. So that 1 hour becomes the turnaround time. But when you look at now the throughput, we are looking at now how many jobs have you executed from 9 to 10? Those are 20 jobs. But how many hours have you taken to complete those 10 jobs or 20 jobs that you have done that? Now we have already taken 1 hour. So in this case, we can say the turnaround time is given as a resultant of what we can say is one of the elements that is supposed to be used in the execution. And it assists in the execution. And when it is assisting in this execution, that's why we need to have what you call the burst time. Sometimes we call it the CPU time. I don't want to call it the CPU time currently. maybe I can call it the CPU time. Then we have the execution time. Please allow me to change this. I don't want to call it the CPU time because the CPU time is the time given to the CPU in the execution. But this is now the time given to a process. So this is the time of a process. Time of a process. So in that scenario, and a way of interpreting that execution that we have, now we can understand that these criteria must be observed. But how will you observe them? So the way we need to observe them is through the use of algorithms. And most of these algorithms, one of them that we have is what you call round robin, fast come fast, shortest job fast, multi-queuing file system, multi-queuing scheduling. But all these algorithms that we have, they are mostly categorized into 3 categories. And that's why we need to look at this. So that's why we are saying process scheduling. Process scheduling is an activity of process manager to handle the removal of the running process from the CPU and selection of another process on the basis of a particular strategy. So we are looking at which process, how we are supposed to select. So that's why we are using what you call pipelining. And we can now organize them in a queue. And when you organize them in a queue, now these processes are able now to execute very clearly. So I don't want to explain on this queue, because if you look at now a queue is how you organize a process or you organize a device, or how you organize a process or how you organize a device. Is it the first one to execute? So that's why I'm saying, using the same model that we already explained, I think this one is just a repetition where we have a running and we have a not running. We must use some schedulers in that execution. And most of these schedulers that we have, one of them is what you call the long-term scheduler, the short-term scheduler, and what you call the medium scheduler. Another name for this, I think you have seen that one, is called dispatcher. Dispatcher. So meaning this process is taking a lot of time to execute. So where is it coming from? It is coming from the external devices. So if now the process is coming from the external devices, now that is termed as a long term, because we are using a long time to execute them. This one is when the CPU, it is in the CPU, when the process is executing. And that's why we have said it is taking less time in the execution. This is mostly used when you are swapping, processes. And when you're swapping a process, we can look at this. Maybe I can use an expression for this. And maybe we can call it swapping here, where we understand that swapping is a process of changing from the main memory to the secondary memory. So in this case, maybe we can say we have an execution. Allow me to use paint, please, for easy drawing. So we are using this as a primary memory. So this is primary memory. Now we are talking about RAM, which is mostly used for execution. And here we are talking about another storage that we are calling the secondary storage. So when you move a process to this point, why? Remember, we can swap a process if the memory was not able to hold all the process. And I think you have never seen a process, an operating system telling you that a process will not execute because the memory is not full. It keeps on picking them, taking them every time and every moment. And when it keeps on taking them every moment, now automatically what you can see within the execution is a point where we can say, if this memory is full and it cannot allow another execution, now automatically that process that was not able to be accommodated with this memory, it is taken to this. So we are doing what you call swap out. But the moment this one is now free and it is able now to accommodate another process, you do what you call swap in. So swapping is mostly working within the operating system with this element that we are calling the medium term. That's why we are saying it is mostly used for swapping processes. And that's why we can see long-term scan determines how program is limited to the system for processing. How will you administer them for processing? We're now moving them from the secondary storage now to the ready queue, then for execution. Short term, we are moving them from the ready queue to the running state for execution. Medium, now that is when you are swapping some processes for that execution. So you will be able to look at now the comparison here in terms of speed, in terms of jobs that can be used in execution. So within this, when you look at the process that you are taking here, and the process is moving from one point to another, that time of changing one process to another, maybe when you're executing job one, when job one is complete, you execute job two, job three, job four, job five. That is what you call context switching. And context switching is part of an operating system element that is mostly used to allow a process from one state to another, or maybe changing of a process from one point to another in that execution. So those ones are the ones that now opens for us what you call algorithms. And we try to understand how these algorithms are able to work at that point. So maybe you can ask a question up to that point so that we can proceed. And I would urge maybe, I don't want to push you with many calculation. Here we'll be doing some calculations here. So I would like maybe we can create a class that you can be able to go through this. And maybe next time we can come earlier, because I was still waiting for, I was waiting you in this lobby for this class. So please, can you ask any question if you have? So you can ask a question if you have, please. Okay, Akinyi, no questions. Ken, do you have any question?
Yes, I have no question.
Okay, so can we proceed? So what I'll do,
yes,
I will start from this scheduling, but I want to give you an overview of what you are supposed to find within the process algorithm. Remember, these algorithms are always classified into two, preemptive and non-preemptive. When you talk about preemptive, we are saying this is an algorithm, or it is where a process can be removed from the CPU, even though it has not completed the execution. But non-preemptive, a process cannot be removed from the CPU when it has not completed the execution. So you must wait for this process to complete the execution. And that's why we have some algorithms that we have here. We have fast come fast serve, we have shortage of fast, priority scheduling, round robin, multi-level. So these are the basic ones that we need to look at, these ones. And those basic ones that we are supposed to look at, if you look at the first job to arrive is the first one to be executed. So in this case, we are looking at now, if you go to a bank, if you are the first one to be attended, you are the first one who arrived first. So in that case, if you are the first one to arrive in that bank, you'll be the first one to be executed. You cannot change. So that becomes now what you call the non-preemptive. You cannot remove that person. Irrespective of any agency, you must wait for that person to complete the execution. Shortest job first, we are looking at the jobs that are very short in the execution, and we execute them fast. And when we complete them, now we can be able to look at now the execution and we complete that execution. So this now becomes either an non-preemptive or preemptive, because if the job is supposed to remain in the execution and it has not completed the execution, and there is another one that is executing, now in this case, we say the job that we are having, one of them is job remaining fast. And then the next one is job shortest job fast. There is job remaining and the shortest job. The shortest remaining is now what you call the preemptive, because you can remove the CPU from that execution. So in that way of execution, you'll be able now to understand these algorithms that we have. and the way these processes are able now to execute in the execution. So, okay, now at least now we can move to the chat room so that we can now be able to communicate. So I will send some question for you to do if there is no question. If there is no question, please, maybe we can move to the chat room and we answer the question that I will send. So I think now we can move to, there are some questions that I will send, and then we will do that. Please do them so that I can mark, please.